Extreme storms in a warming world. Extreme weather events, tornadoes and hurricanes, are becoming more intense and destructive. Scientists have observed rising wind speeds, longer-lasting storms, and increasing economic and human losses from these natural disasters. While weather has always been unpredictable, global warming is amplifying the energy available in the atmosphere and oceans, creating conditions for more powerful storms. Understanding how climate change fuels these events requires examining the underlying physics, atmospheric dynamics, and the interplay between heat, moisture, and wind. How tornadoes form. Tornadoes are rapidly rotating columns of air that extend from severe thunderstorms to the ground. They typically form from supercell thunderstorms, which have rotating updrafts called mesocyclones. Three key ingredients are needed for tornado formation: warm, moist air near the surface, cool, dry air aloft, wind shear, changes in wind speed and direction with height. These conditions create instability and rotation. Traditionally, tornadoes have been concentrated in the U.S. Midwest, known as Tornado Alley. However, in recent years, tornadoes have appeared outside these regions, and their intensity is rising. Global warming directly impacts some of these factors, particularly moisture availability and atmospheric instability. How hurricanes form. Hurricanes, also called tropical cyclones or typhoons depending on the region, form over warm ocean waters. They require sea surface temperatures of at least 26.5 degrees Celsius, 80 degrees Fahrenheit, high humidity in the lower and middle atmosphere, low vertical wind shear, a pre-existing disturbance to initiate rotation. Hurricanes derive their energy from warm ocean water. The warmer the water, the more latent heat is released into the atmosphere, fueling the storm's intensity. Global warming increases ocean temperatures, which makes hurricanes stronger, wetter, and more destructive. Global warming and atmospheric moisture. One of the most direct ways global warming affects storms is through increased atmospheric moisture. Warmer air can hold more water vapor, roughly 7% more for every 1 degree Celsius rise in temperature. More moisture means that thunderstorms, including supercells that spawn tornadoes, have more energy to draw upon. For hurricanes, increased moisture results in heavier rainfall, stronger storm surges, and more catastrophic flooding. Hurricane Harvey in 2017 is a prime example. The storm stalled over Houston, and record-breaking rainfall led to massive flooding. Climate scientists estimate that global warming amplified Harvey's rainfall by 15 to 38%, demonstrating how warming oceans and atmosphere combine to intensify storms. Rising sea surface temperatures in hurricanes. Ocean heat content is crucial for hurricane formation. Global warming is causing higher sea surface temperatures across most tropical oceans. Hurricanes feed on this heat. The warmer the water, the more energy the storm can extract, resulting in stronger winds and lower central pressures. Warmer oceans also increase storm surge risk, as rising sea levels mean that even a moderately strong hurricane can flood larger areas. This combination of higher winds, heavier rain, and elevated storm surges makes hurricanes deadlier than in the past, particularly for coastal communities that may be unprepared for these amplified events. Tornadoes and climate change. Increased instability. Tornado formation depends on atmospheric instability, measured by convective available potential energy, Kp. Kp values increase when the lower atmosphere is warm and humid while the upper atmosphere remains cooler. Global warming contributes to higher surface temperatures and increased humidity, both of which raise Kp and make storms more likely to produce tornadoes. Additionally, moisture-rich air allows thunderstorms to sustain stronger updrafts, which can generate EF3, EF5 tornadoes. While the total number of tornadoes may not be rising dramatically, research indicates that the intensity and duration of the strongest tornadoes is increasing, leading to more widespread destruction. The role of wind shear and tornado intensity. Wind shear, the variation of wind speed and direction with altitude, is crucial for tornado development. Climate change may influence wind shear patterns by altering the jet stream and upper-level atmospheric circulation. In some regions, this has created conditions that sustain rotating storms longer, allowing tornadoes to cover greater distances and reach higher intensities. As a result, tornadoes that might have dissipated quickly in the past can now travel dozens of miles while maintaining destructive power, causing higher fatalities and economic damage. More intense rainfall and flooding. Both tornadoes and hurricanes are becoming rainier due to global warming. For tornadoes, supercell thunderstorms can produce extreme localized rainfall, leading to flash flooding. For hurricanes, warming oceans and moisture-rich air produce slower-moving, rain-heavy storms, increasing the risk of prolonged flooding events. Economic costs rise sharply with flooding because water damages infrastructure, homes, and crops. Human survival is increasingly challenged, not just by winds, but by the secondary effects of extreme rainfall intensified by a warmer climate. Hurricanes moving slower and stalling. Recent research shows that hurricanes are moving more slowly over land, a phenomenon linked to climate change. Slower-moving storms dump more rain over the same areas, worsening flooding. Examples include Hurricane Harvey in 2017 and Hurricane Florence in 2018. Economically, slower hurricanes strain emergency management, disaster relief, and insurance systems. Communities face prolonged exposure to hazards, and infrastructure recovery becomes more costly and time-consuming. This demonstrates that the economic impacts of climate-driven storms are rising alongside their meteorological intensity. Compound effects and feedback loops. Global warming not only intensifies individual storms, but also creates compound hazards. Rising sea levels amplify storm surges during hurricanes. Higher temperatures increase moisture content, fueling heavier rainfall. Simultaneously, urban expansion and deforestation exacerbate flooding by reducing natural drainage. These feedback loops make extreme weather more deadly. A combination of stronger winds, more rainfall, and vulnerable infrastructure multiplies the human and economic toll of tornadoes and hurricanes. Scientists warn that without mitigation, these trends will continue and worsen, especially in densely populated coastal regions. Economic and human implications. The increasing intensity of tornadoes and hurricanes carries enormous economic consequences. Insurance claims, property damage, disaster relief spending, and infrastructure repair costs are rising sharply. For instance, the U.S. suffered over $100 billion in hurricane-related damages in 2020, a figure projected to increase with stronger storms. Human costs are also profound. Deaths, injuries, displacement, and loss of livelihoods disproportionately affect vulnerable populations. Climate-driven storms highlight the intersection of environmental change, economics, and social justice.